In this homework video guide, we will evaluate the following limits, and for these limits, x is going to positive or negative infinity. So when we're dealing with limit questions where x is going to positive or negative infinity, we always want to identify the highest power in the denominator. So the highest power in the denominator is x to the power 2. And what we're going to do mathematically is that we're going to divide everything on the numerator and everything on the denominator by x to the power 2. So on the numerator I have x plus 1, which is totally fine. And then I will divide that by x squared, and I'll divide this by x squared. And then we also have the denominator here of x squared minus x. And basically this will also be divided by x squared and divided by x squared. Now, although this looks different, mathematically we haven't changed the original problem because we divided every single term in the original problem by x squared. Okay, so let's go ahead and just simplify this now. So I have equals to the limit as x goes to positive infinity. And if I take a look at this first term here, x divided by x squared, that's going to simplify to 1 over x. And then plus the second term, which I cannot simplify, so I'll leave that as 1 over x squared, all divided by, and then if I have x squared divided by x squared, I have a 1, subtract, and then x divided by x to the power 2 is going to be 1 over x. Okay, so this is looking pretty good to kind of start off this very first problem here, and what I can do next is I can do a direct substitution step here. So if x is going to infinity, all of these x's are going to be infinity, right? And one of the things that we learned in class was that if you have 1 over infinity, which is 1 over a really big number, this is the same thing as getting like 1 out of like, you know, a very huge number, right? So it's kind of like we have a test and maybe it's out of like 1 billion marks and you get 1 question right. Well, even though you got 1 question right out of 1 billion, this is still pretty much close to 0%, right? So how does that translate to this particular problem here? That means that everything here where we, if I change all these x's with infinity, so infinity squared is still going to be infinity, and this is also going to be infinity. Everything with an infinity on the denominator means that all of this just goes to 0. Alright, so if we start evaluating this now, or putting this all together here, I have 0 on the numerator and 1 on the denominator. It turns out that this 1 actually survives, but 0 over 1 is going to be 0. So that limit equals to 0 there. Okay, so let's take a look at a graph of this. So if I had to graph the function here, what this basically means is that when x goes to infinity, that means the graph is going forever to the right, right? We're going forever to the right. The height that we approach, it's got this asymptotic behavior, and the height that we approach is also going to be 0, right? So that's what this limit means. We're going forever to the right, and we want to know what height do we level off at, and basically we're finding a horizontal asymptote. So when our final answer was 0, that means the horizontal asymptote is at y equals to 0. Okay, let's move on to the next question here. So I have a limit as x goes to negative infinity. So once again, it doesn't matter if you're going to positive or negative infinity. We still need to find the highest power in the denominator. And in this case, I have x to the power of 4. Okay, so we're going to divide every single term by x to the power of 4. And if I do that, the first step is generally takes the longest. So x goes to negative infinity. And then I have the original problem as 3x to the 5 minus x plus 4, and every single term is going to be divided by x to the power of 4. All right, and then I divide this by 2x to the 4 plus x, and all of this will be divided by x to the 4 and divided by x to the 4. So mathematically is totally fine if you divide every single term by the same thing. Although the question looks different, mathematically it's the same problem, right? Okay, so now we need to simplify this. Okay, so over here I have 5 x's on the numerator and 4 x's on the denominator. So what really survives is just 3x. And over here I have 1x on the numerator and 4x's on the denominator. So if I simplify that, I get negative 1 over x cubed, and then plus 4 over x to the 4 as my last term. Then on the denominator, I notice that this x to the 4 and that x to the 4, that will cancel, giving you just 2, plus, and then finally x divided by x to the power of 4 is 1 over x cubed. Okay, once we do a direct substitution step, I can definitely say that all of this goes to 0. And then we're kind of left with this 3x and this 2, right? So what's really happening is that the 3 survives, and we're actually inputting negative infinity into the expression, and we're dividing it by 2. Okay, so that negative infinity goes in for that x value right there, right? So let me get out my marker here. So that negative infinity goes in for there. So here we go. We have 3 over 2 times negative infinity. Well, 3 times negative infinity, you can think of that as 3 times a really big negative number, which is going to be negative infinity. And if we still divide a huge number by 2, I mean, we still have a huge number of negative infinity there. So that's what it looks like for that particular problem. Okay, let's take a look at the graph here. Here's my graph of the function here. And once again, we're going to negative infinity, right? So this graph doesn't show all the details, but we're going forever to the left, right? So if I go forever to the left, that means we're going to negative infinity. And what's happening to the height as I go to negative infinity? Well, if I follow the path of this graph, it looks like this graph, it keeps on going to a negative height of negative infinity over here, right? So we go forever down, so we say the limit is approaching, as we go to negative infinity, the height is also going to negative infinity. Okay, let's go on to question number 4 here now. Okay, so once again, the limit for this problem, x is going to infinity for this limit, so we need to look for the highest power in the denominator. In this case, we have x to the power 2. Okay, so as we do our limit problems here, I have a limit as x goes to infinity, and then I can rewrite all the individual terms as 3x squared plus 1, and that's going to be divided by the highest power in the denominator. Okay, and then now we can simplify this. So once again, if we divide every single term by the same thing, we're still mathematically that's still okay. And then x squared and x squared, that cancels, giving you a single 3 plus 1 over x squared all over. And then the x squares and x squares cancel, giving you a 5 minus 2 over x squared. And then when we do a direct substitution step here, this will go to 0. That will go to 0, and you're finally left with 3 divided by 5 as your final limit there. Okay, it's not too bad. Let's finish off with showing a quick little graph of what's happening in this particular case. So here's my graph of the function here. And once again, when x goes to positive infinity, it means the graph is going forever to the right-hand side, right? So what's happening to the graph as I go forever right? Well, the graph is leveling off, but it's not leveling off to 0. There seems to be a bit of a height here, and this height is going to be 3 over 5. Okay, so 3 over 5 is the height that we're roughly leveling off at. So we're definitely a little bit above 0, and the height is 3 over 5. So that's our horizontal asymptote there. Okay, let's go on to question number 6 here. So now I'm going to negative infinity. Okay, so we must find the highest power in the denominator. Which in this case is going to be x to the power of 5. All right, so if I write out a limit statement, this will be the limit as x goes to negative infinity of 2x to the 4 minus 4x, and we will divide every single term there by x to the power of 5. Divide that by x to the power of 5. And then on the denominator, I have x to the power of 5 plus 9x minus 5. And we're going to divide every single one of those by x to the 5. Divide that by x to the 5. And divide that by x to the 5. Okay, here we go. Let's go ahead and simplify this. Okay. And then let's go ahead and simplify the x variables there. So I have more x's on the denominator there. So if I simplify this, this will be 2 all over x minus 4 all over x to the power of 4. All right, so there's 1x there and 5x's there, so we should have 4x's on the denominator. Divided by, okay, so x to the 5 divided by x to the 5 is simply going to be 1 plus 9 over x to the 4. And then finally we have negative 5 over x to the power of 5 there. Okay, so it turns out that all of this goes to 0, 0, 0, and even this goes to 0, right? So on the numerator, I guess we have 0 on the numerator and we have a 1 on the denominator, and 0 over 1 is going to be 0 there. Okay, so let's take a look at the graph here again. All right, this graph is a little bit better because now I'm going to negative infinity, right? So I'm going forever to the left. And what's happening to the graph here? Well, if I follow the graph, as this graph goes forever to the left, then it gets closer and closer and closer and closer and closer to a height of 0 there. So that's what's happening to that particular graph. If I go forever left, which is negative infinity, the height that I approach is 0, which is our horizontal asymptote. And that concludes that question there. Okay, we've got a few more of these problems here, so we'll try to get through them here. So for example number 2, on the next page here, I need to find the equation of the horizontal asymptote for each rational function and then use limits to justify your answer here. Okay, so definitely you can apply some pre-calculus 11 concepts to find the to find the horizontal asymptote, but I'll just jump right into the limit statement here. So when you're finding a horizontal asymptote, essentially you're writing a limit statement, and really x can approach either positive or negative infinity, and your function will be 1 minus x squared all over 2x squared plus 1. So when you're asked to find the horizontal asymptote, you just need to set up a limit statement like that, and then you approach it like any other question going to positive or negative infinity. So we look for the highest power in the denominator, and in this case it's going to be x squared, so this is nothing new. The highest power in the denominator is x squared, and then we just solve it just like all the previous problems on the other page. The only difference is that when you write your limit statement, you're going to write plus or minus infinity. And then we have 1 minus x squared, and that's all being divided by x to the power 2, x to the power 2, all divided by 2x squared plus 1 divided by x to the power 2 divided by x to the power 2. Okay, so that's very similar to what we did in the previous questions there, and now we need to simplify this. Let me just continue on here. Let me use a blue marker now. So I have the limit as x goes to plus or minus infinity. Okay, so the very first one I have 1 over x squared minus, and now I have x squared over x squared, which is 1, so minus 1, divided by, okay, the denominator here, x squared and x squared, that cancels, giving you a 2 plus 1 over x squared. All right, and it turns out that this term here and that term there, I mean, those just go to 0, right? And ask yourself what survives. Well, there's a negative 1 on the numerator and a 2 on the denominator, so that final answer is going to be negative 1 over 2. So my horizontal asymptote is at y equals to negative 1 over 2. And let me just kind of finish off by showing a little diagram of this particular question here. So once again, for this, so here's a graph from Desmos here. Here's one side as x goes to positive infinity, and here's the other side as x goes to negative infinity. And it turns out that if we go forever to the right, the height that we approach here is going to be negative a half. Okay, and then if we go forever to the left-hand side, which is negative infinity, this height here is also going to be negative 1/2. Okay, so these are the heights at the tail ends here. So it turns out that the vertical asymptote is negative 1/2. That's the height that we approach when we go forever left and when we go forever to the right. Okay, so move on to question number 7 here. And I like question number 7 because there's this plus 3 here, right? So we got to make sure we take care of that correctly here. Now, when you're looking for a horizontal asymptote, I would start off by writing a limit statement as x goes to positive and negative infinity of 6 all over x minus 2. Now, instead of writing this plus 3, instead of doing that, I'm going to take my limit statement and I'm going to distribute it on. So I get the limit as x approaches plus or minus infinity of just 3. Okay, so that limit sign is distributing on to the rational function and the 3. So we have two separate limit statements here, right? Okay, so when we're doing this question now, we still look for the highest power in the denominator. Okay, and that's going to be just a single x, right? Alright, so let's go ahead and now solve this limit problem here. So I have the limit as x goes to positive or negative infinity. Then I have a 6 here, and that 6 will be divided by an x. All divided by, I have an x minus 2, and all of that will be divided by an x, and that will be divided by an x. Now over here I have a plus, this limit as x goes to positive or negative infinity, but we just leave it as a single 3. Okay, so that 3 is not part of the rational expression, it's a separate term, and it's just a constant there, so we're going to leave it there as just 3. Okay. If I keep on simplifying here, I mean x over here, I mean I'm not going to write another limit statement there because I just want to save a little bit of time here, but x over x is simply just going to be a 1. Okay, and then it actually doesn't matter because this thing will go to 0, that thing will go to 0, so you really have 0 over 1 plus this limit as x goes to plus or minus infinity of just 3. Okay, so you got to think about, like, what does this really mean? Well, this is going to be 0 plus, and then what does this really mean? Well, if you think about a graph, 3 is just a horizontal line, right? You know, we learned this in grade 9, y equals to 3. It really doesn't matter if you go forever right or forever left. The height is always going to be 3. So this limit right here in the red box, that limit is simply going to be 3. So 0 plus 3 is going to be 3. Okay, so let's take a look at the graph here. Here we are. And let me just draw a horizontal dashed line here, because if I go forever to the right, the height that I approach is going to be 3. And if I go forever to the left, in this direction, the height that I also approach is going to be 3, right? So if I go forever right or forever left, the heights that we approach are 3. So that's my horizontal asymptote there. Okay, so hopefully that graph will help you get a visual idea of what our answer really means. If we go forever left or right, the height that we approach is going to be 3 on both sides of the graph. Okay, let's move on to another question here. So we need to find the horizontal asymptote here. So if we're looking for the horizontal asymptote, the limit as x approaches, I'll put this in red now, plus or minus infinity, that gets distributed to the negative 2x all over x minus 1 plus, then we have another limit statement here as x goes to plus or minus infinity, and that constant here right now is going to be a 4. Okay, so we just distribute that limit property twice into both those terms there, the rational function and the plus 4. Okay, so since we're still going to plus or minus infinity, we look for the highest power in the denominator, and the highest power in the denominator is going to be an x. So, you know, we've done this like a few times in this homework video guide here, and it does get annoying to keep on writing out all these limit statements here. So there's a negative 2x, and then we divide that by x, and then we divide that by x minus 1, and then we'll divide it by x, and divide that by x, and then we have this plus the limit as x goes to plus or minus infinity of just 4. Okay. Alright, so let's think about this. I have an x and an x, so x over x is going to be like 1. So I guess if I have to write another limit statement here, I get x goes to plus or minus infinity, and negative 2 on the denominator, and then x over x is going to be a 1, so 1 minus 1 over x, and then plus. Now, we kind of talked about this in the previous example there, where you have a limit going to positive or negative infinity of a constant, and the answer is just going to be that constant, right? And then over here, I know that this will go to 0, so this limit will simply be negative 2 over 1 plus the 4 and negative 2 plus the 4 is going to be positive 2. So when I go to positive or negative infinity, the height that I approach is going to be 2 on both sides. Okay, so let's do a graph of that to finish this off. So here's my graph of x going to positive or negative infinity. So here I go positive infinity that way, negative infinity that way. And the height that I approach here, this green line, is simply going to be 2 on both sides. Okay, so that's what we just kind of did for that particular problem there. All right, we're almost done here. I think I have 4 more problems to go, and the next few questions on the next page. These ones are a little bit easier because you need to find the equation of the horizontal asymptote, and then you need to justify it using limits. All right, so if I look at this graph here, I mean, here's my horizontal asymptote in blue, and the equation of that blue line is y equals to negative 2. So there's the equation of the horizontal asymptote. And the horizontal asymptote happens when I go to positive infinity. So I write a limit statement. The limit as x goes to positive infinity of this function f of x, and that levels off to a height of negative 2. And that is the limit justification right there. Okay, and that's it. Let's move on to the next one here. So for this particular graph, if I draw out these horizontal lines, what's the equation of that green line? Well, it's y equals to 2, so that's the equation of the horizontal asymptote. Now, it turns out that it doesn't matter if I go to negative infinity or positive infinity. So if I go to positive infinity or negative infinity, it really doesn't matter. It turns out that when x goes to positive or negative infinity, this function will still have a height of 2. So there's my limit statement to justify the horizontal asymptote. Yeah, so these questions are a little bit easier. We're just kind of reading the graph here, and for this next one here, it looks like I have 2 horizontal asymptotes. So if I go to positive infinity, this equation is y equals to 2, and if I go to negative infinity over here, I guess I'm running out of space here, but the equation of that graph is going to be y equals to negative 2, right? So those are my 2 horizontal asymptotes. So I'll say y equals negative 2 over here as well. Okay. All right. So how do I write this part of the limit statement? Okay, that's the limit as x goes to negative infinity of f of x, and that equals to a height of negative 2. And if I want to write this limit statement over here, that would be the limit as x goes to positive infinity of f of x, and that reaches a height of positive 2. All right, so those are my 2 limit statements to finish off that particular question. Okay, last one here. If I look at this green line here, I guess the equation of that green line is going to be y equals to 1. So I guess this graph will level off at a height of, sorry, not 1. It's below the x-axis, so negative 1. So there's my horizontal asymptote. I'll say HA, horizontal asymptote. And once again, if I go forever to the right, and if I go forever to the left, it turns out that the height that I approach will always be negative 1. Negative 1 there and negative 1 over there. So how do I write that statement there? I write down the limit as x approaches positive or negative infinity of f of x, and that has a height of negative 1. Okay, so that should do it for this homework video guide.